Hello, student. So, last class, that is in the that previous class, we have discussed about uh, what the relation in terms of weight. Okay. So till now we have discussed about three-phase diagram of soil. Okay. Then different relation in terms of volume, different relation in terms of weight, and also we have discussed some interrelation between volume and weight. Okay. So we know already about what is void ratio, porosity, degree of saturation, specific gravity, unit weight of soil, dry density of soil, submerged density, submerged unit weight, saturated unit weight, saturated density, isn't it? And what? Yeah, all these things we have already discussed in the last classes. Okay, so today we'll discuss about index property of soil. Okay, in general, a soil mass is considered to be containing two types of property. Okay, so first is your index property of soil and other is your geotechnical property of soil. Fine, I'm again repeating, a soil have two types of property, two kinds of property. Okay, so first kind is what? Index property, and other kind is what? Engineering property or geotechnical property. Fine. So what is the difference between these two property? So in this property is characterized the soil. Okay, so to identify a particular soil you have to know its index property. Okay, and the other engineering property or uh, geotechnical property are actually related to your engineering purposes. That means your X second meeting slot. Okay, engineering property, they are applied property for our, it is used in case of application of soil. Fine, there is the main difference between index property and geotechnical property. Okay, so let's share, let me allow the sharing the screen. Okay, wait. Okay, can you see the screen? You can just respond in chat box. Is the screen is visible?
Sir,
Okay, wait. Okay, so we'll discuss about index property of soil. Okay, it's class 4. Okay, can you see this slide? Can you see this screen? Word file? This is a class note for uh, class 4. Okay, so you will get this in student portal. So the title is index property of soil. Okay, so I think here you can see basically in soil mechanics, properties of soil are broadly classified as index property and engineering properties. Fine. So the properties of soil which are used for identification and classification are called as index property of soil. Okay, and index properties are actually meant to classify the soil or identifying the soil. Fine. And under index property, how many index properties are there in total? I guess how many? I think 6. Okay, so specific gravity, that we have already discussed in the last class. Sorry, yeah, last class we already discussed specific gravity of soil or specific gravity of soil solid. Water content, particle size distribution, it is the new term that we're going to discuss. In situ density, density we already discussed. Density is what? Mass per volume. In situ means at field. Okay, at field, that means in nature, what is the density of soil? It represents in situ density. Okay, at site, what is the density? It represents by in situ density. Next, consistency limit. It is a very important term, especially for fine grained soil. Okay, and then relative density. Okay, or density index. So these all are index property that we are going to discuss. So for particular soil, for classification or for identification of a particular soil, you need to know this parameter, this property: specific gravity of the particular soil, water content or moisture content, particle size distribution, in situ density, consistency limit, and relative density. Fine. So we're going to discuss about index property now. Besides, we have some engineering properties are also, that is like permeability, shear strength, compressibility. These are engineering property. Okay, we are going to discuss in a coming classes. I think Chinimuni ma'am, we are discussing about this compressibility with you. Okay, so let's discuss about first specific gravity. I think we have already discussed about specific gravity. What is specific gravity? It is a ratio of soil solid to the weight of equal volume of water content at 4 degrees standard temperature. Okay, that means why 4 degree standard temperature? Because at 4 degree Celsius, um, the water attained its maximum density. Okay, and there is some information how can you determine specific gravity using a pycnometer method. Okay, I think in the ERP also you will get this information about how to total module or procedure, how to find out specific gravity of particular soil in laboratory using pycnometer or density bottle in laboratory. I think you will have some material in ERP or in a student portal. Okay, so it will be like this. I'm not going to elaborate this procedure now. Okay, so I just left here. Just know this. This specific gravity can be determined by a pycnometer method. Okay. Okay. Let's go to first, then here. Okay. Yeah. So I think we have already discussed about this. So index property, these are the index property, and these are engineering property. Okay. So we already discussed about specific gravity. So here you can see the diagram of pycnometer. Okay. So this is a pycnometer. So this is also available in our laboratory. So you can also find out a video link in your student portal, also a manual detailed procedure how to find out specific gravity of a particular soil. Okay, which is ranges from 2.6 to 2.8 for inorganic soil. Okay, it is not that tough. It is very simple experiment. You will just go through that notes and video. Okay, yeah. The next we'll discuss about water content. Fine. So determination of water content. So water content, we already discussed what is water content. So it is defined as what? It is defined as weight of water to the weight of solid present in a soil mass, isn't it? You can just refer to the last notes. That is moisture content or water content. It is defined as the ratio of weight of water, that is WW, to the weight of solid, that is WS, in a given mass of soil, and it is expressed in terms of percentage. Okay, and it can be determined by different methods. To determine water content, we have different method, and like I'll just give a list of that method. I think you can see here also. Wait, a second. Okay, let me take the notes. Hold on. So water content can be determined by different method, like you can see here. Oven dry method, sandbath method, picnometer method, and rapid moisture meter. Rapid moisture meter, or okay, these are the method can be used for determination of water content. Fine. Among this method, oven drying method is considered as the most accurate method. In our laboratory also we have this method. Okay, we can follow this method. That is oven drying method. In this method, we use what? Oven. Okay, thermostatically controlled oven. Okay, so oven dry method is considered as the most accurate method for determination of water content. Mind it. Okay, and that calcium carbide method. I think it is not written here. Calcium carbide method. Calcium carbide method also one of the uh, method that is also another name of calcium carbide method is rapid moisture meter. Okay, it is also known as rapid moisture meter. So it is considered as a quickest method. Okay, okay, hold on. I have just got a call from our engineering, your exam control department. Okay, excuse me. Let me take the call. Okay, hello. Oh, sir. Hi, sir. Okay, ইয়াৰ আছে sir. Okay, okay, sir. তো এইটো মানে নৰ্মেল নৰ্মেল লিংকতে হ'ব sir. Okay, ঠিক আছে. Okay, sir. Thank you, sir. Okay, sir. Okay, sir. Okay. Yeah. So this calcium carbide. Oh, what am I? Yeah. This calcium carbide method is considered as a quickest method to determine moisture content. Okay. So in some exam, it will sometimes ask, okay, which one is considered as the most accurate method to determine moisture content? That is oven dry method. And which one is considered as a quickest method to find out moisture content? That is your calcium carbide method. Okay, so we can also go through the other method. It is sandbath method is there, picnometer methods also be there. Okay, so I think in your student portal you will get all the details of this method, especially this oven dry method. Okay, you will get information about oven dry method, how to find out moisture content in laboratory by using oven dry method. Okay, give me 1 second. Okay. Yeah. So yeah. So after all, mocha content, we'll discuss about determination of particle size distribution. Okay. So particle size distribution. Before going in this manual, let me tell you what all about this particle size distribution. Okay, so in this class we only discuss about this name of the test. In coming classes we'll go for in detail what is particle size distribution, why this needed. Okay, we'll discuss in detail. Fine. So for now, just mind here, the particle size distribution can be determined by two methods. Okay, first one is for coarse grain soils, second for fine grain soil. Okay, we'll discuss these things in coming classes. For now, just try to listen. For coarse grain soil, we have two. That is dry sieve analysis and wet sieve analysis. For fine grain soil, we have again two. That is sedimentation analysis or hydrometer method. Okay, so these are all are related to your particle size distribution. Okay, how to find out grade of soil. Okay, we'll discuss about what is grade of soil in coming classes. Next, yeah, next we have determination of in situ density of soil. We already discussed what is density, isn't it? Density is defined as a mass per volume of a soil. We can also find out density, that is in situ density means what? At field. At field, we can also find out the actual density of soil by using these two methods. What is this method? One is your core cutter method, another one is your sand replacement method. Okay, so here you can see the diagram of these two apparatus. This is for core cutter apparatus and this is your sand replacement apparatus. Both apparatus are available in our laboratory, but in generally we go for core cutter method for practicing. Okay, so if there is maybe a physical class, we will go for this. Otherwise, you just go through your student portal, you will get the video link and also a manual or detailed manual how to do this test. I think it is very simple and very easy to understand. Okay, so till now we'll not go for further discussion. I'm just in this class, I just want to discuss with you that mind it, the soil have two type of property, that is engineering property and index property. Fine. Engineering properties are this, that is specific gravity, water content, particle size distribution, in-situ density, consistency limit, and relative density. Fine. And other engineering properties are permeability, shear strength, and compressibility. Okay, they are applied or application property. We can in other word you can say that. But to know the soil, to identify the soil, you have to know this property. Okay, so it's like your work. At least you just go through these things. Okay, I think we already discussed about specific gravity, water content, and density. Fine. Only some new things are coming here: particle size distribution, consistency limit, and relative density. Fine. So we'll discuss in detail what is particle size distribution, what is consistency limit, and what is relative density in next class. Fine. And simultaneously, you will also get to know about permeability, okay, shear strain, and compressibility in coming classes. Okay. So I don't want to give so much information in one class. So next class will continue from this. Is it okay for you? So is there anything to ask for the particular this class? You can ask me now. You can just respond. If you have any doubt, you can ask me. And if you have understand till now, just you can respond yes or no. I think it's very easy to understand. Okay, but thing is that in the basic thing, right? Because we are discussing basic things. There are very small concepts are there. Okay, mind it. Very small definition, very small things to understand, but there are large numbers of things are there. This is the main problem. Fine, there's very small thing, tiny thing, but in a large volume. You have to go through this very all detail, but all things are very simple and understandable, very easy to understand. Okay, so you have to be very patient. Okay, you go through each and every point. If you got any doubt or somewhere you just got stuck, you just consult me, you just text me, or you can just call me. Okay, so till now we have discussed about specific gravity. You can go through textbook or notes or video link, it's given to you. Go through this water content, you can find out how to find out in laboratory using oven dry method. Okay, and this in-situ density, you can find out this. In coming classes, we'll discuss particle size distribution, then consistency limit, and relative density. Okay, so I'm just closing this, I'm just stopping the recording for now.